About cloud technology. We heard some nice announcements this morning about making cloud invisible.
Yeah.
That's already a message we heard, I think, also in London. Making cloud invisible, it means that making a cloud transparent for the user, isn't it? That's your idea. So you use the cloud services, but you're not aware what cloud you're using, where the data is based. It's just a feature in the feature set of your environment.
Yeah, I mean, there are more ways of understanding the visibility of cloud. One is from the user's perspective, but more importantly from the IT team's perspective, right? If you look at right now, what the IT teams are facing is this challenge of, hey, I want to continue to use on-premise private cloud something, and then I have to also start using public cloud because that's where my CIO wants me to go, right? Now, from a skill set perspective, the private and the public are different, right? And therefore, from a team perspective, it's actually a lot of enterprises splitting out. And then the budgets that come from the CIO, okay, now this year I'll invest this much in on-premise and this much in the cloud, and that even the budget splits. And that makes cloud actually not invisible in the sense that, we need to decide this cloud or that cloud. That's the basic question. Right?
Mm-hmm.
So all the discussions that are happening in enterprises, okay, which cloud will it go in? That is not invisible cloud. To solve that, it's not as simple as you just put a layer of cloud management platform on top and the user cannot see it. We have to go deeper. We have to say, look, from a CIO's perspective, CIO needs to hire one team, which is the cloud team, and this cloud team can manage on-prem and in the cloud using the same skill sets. Right? Once it's the same skill sets, it's the same team, then you can not have to. You don't need to split the budget. It needs to be that they purchase from a vendor some technology, and then now they can use the technology anywhere they want. Right? Once you achieve that, then in every meeting the question is not, okay, which cloud is it, on-premise, then which team. The question is, okay, here's an app, let's run it wherever it makes sense, and if it doesn't work, we can move it away to something else. And that's what we are trying to do. So make the source of this tension go away from the IT teams. They are first. They are our customers. We want to simplify their lives, and then the choice between private and public, and which public, we want to make it as simple as possible for them, so that they might make one decision today and change it later. There's no lock-in. There's no Hotel California syndrome that's happening. So that's what we're doing.
But to what extent are the clouds different for the IT engineers? If you run an AWS on-prem or at Amazon, it's the same cloud service. So I think the APIs and the management is absolutely the same.
Yeah. So that exactly right. So that's what we are seeing. There's a secular trend in the market where all the cloud vendors are trying to provide the same thing on both sides, so that this friction goes away. Right? Now AWS on-prem, when it comes, it will solve that problem. Right? From an AWS perspective. From like Azure has Azure Stack for some years already. It's trying to solve that problem. What we are doing is we are trying to say, look, we want to be almost like the Switzerland of computing, right? Which is, it doesn't matter whether it's AWS or Azure or Nutanix or our own data centers. What we would like to do is make sure that you can move from one cloud to the other, change your mind without any lock-in anywhere.
But to what extent is this approach a risk for the cloud vendors?
For the cloud?
Yeah, because if you make it fully transparent and if you make it as universal as possible, because it's managed by your software, how can cloud vendors then differentiate from each other?
Ah, okay.
So
cloud
not,
vendors, right?
not on the price. Yeah. The price is the most worth asset to compete on, so there must be something different.
Correct. So right now what we're talking about is, see, we have the lens of our customers, they're enterprise customers, right? And enterprise customers are running a whole bunch of classic apps, be it databases, Oracle, SAP and all that, right? What we want to do is to give them the ability of running that in the cloud of their choice without getting locked in there, so they can migrate to the cloud. If they don't like it, they can come back and move to another cloud. Right? So that's what we are providing right now. So in terms of just the IaaS layer, that's what we're providing. So equate that to on-premises when I have to choose a server vendor. It could be HP, Dell, could be Nutanix itself, right? So that's the differentiation. Now, you would say that the server vendors, they're not much differentiated, right? There's a small margin that they have. The cloud bare metal is going to follow the same suit, right? Basically, it's a bare metal service. If everybody starts offering it, there would not be much differentiation at that layer. So, for the traditional enterprise applications, which Gartner would call Mode 1 applications, I don't think there's much differentiation beyond that. So the cloud is providing servers as a service, right? Now, the bet that the cloud vendors have is once you migrated your legacy applications into the cloud, you will be attracted to the PaaS services that they have, and that's the differentiation, right? And you'll start consuming them, and it's good. It's good for the customer and also good for the cloud vendor, that now the customer can leverage the AI, ML, big data, and all sorts of other applications that are there in the cloud. And that would actually decide for the customer, what do they want to do, right? Do they want to go to a particular cloud because they take their Mode 1 applications and migrate it to cloud, but then now they're in close proximity to the other services? That's the differentiation.
So the differentiation is coming from on-top services, and not from the main feature set.
Not from the IaaS layer. IaaS layer is going to get commoditized.
This morning, Sunil made an announcement that he was thinking that in the future, when you come back from your job, you park your car in the garage, and then the car makes itself available for
taxi or something.
Taxi or something like that.
Yeah.
What kind of infrastructure is needed to make autonomous driving possible? We know that most of the intelligence will be in the car and not in the network.
Yes. See, this is a natural evolution of computing, right? Computing has always been in layers, right? There's always like the laptop that we have that has a central processing unit, and then beyond that there are some daughter cards for maybe networking and for managing the keyboard and mouse and camera and so on, right? It's always been in layers. With data centers, it's the same thing. You have a central data center, call it the big public cloud that you have, where you have all the data sets and all the data crunching that you want to do, right? And then there are layers closer and closer to the edge devices, if you will. Analogy is human body as well. There's a central brain, the big brain, that's your central cloud. All the data sets, big crunching. Then there's a spinal cord, which is, it has some small data set, but it's for quick actions.
Yeah, for instance, if you burn your finger,
it doesn't go to the brain. Right?
No, it stays in your finger.
So quick decisions, and then finally it goes to nerves, and then there is some amount of calculation right there in the fingertips to figure out what kind of. So there's like data purification that happens at the edges. Any computing that has happened in the world, right, whether biological or silicon, has followed this. So going back to your self-driving car analogy, the public cloud itself can't do it.
Oh.
So the edge has to get smart. Now what will the edge do? Learning from our edge senses. What the edge senses are good at is they take humongous amount of data coming in and then distill what's really relevant to send to the mothership, right? And so the car is going to get a lot of video and process it locally and figure out some local actions, that's the spinal cord kind of thing, and then some of the anomalies that it cannot figure out will actually be sent to the public cloud or the central brain. And then the central brain is actually gathering this not just from one place but from thousands or maybe millions of cars, and then figuring out how the algorithm needs to change. And that's how humans also learn. When we are riding a bike for the first time, it's our central brain that's riding the bike, and you learn it and you fall and all that. And after some time you learned the model, and now the model is pushed down your spinal cord.
I was not aware. So
Right? I mean,
this is a nice.
right. And then you don't think about the bike at all because your central brain is no longer needed. Same thing is happening in the public cloud, right? With machine learning, the anomalies or anything new that you have not seen before goes to the cloud. You learn the models and push the models back down. And when you push the model back down, now the public cloud doesn't have to do anything. So in all of this, what is key is you need a substrate that allows this to happen. So in the biological world, that substrate is called neurons, right? It's neurons in my brain, neurons in my spinal cord, neurons up to my fingertips. In the silicon world, in your laptop, it's basically transistors and silicon. I mean, it doesn't change media. It doesn't go from silicon to something else. And in the data center space, the same thing is needed. If you have chosen an operating system, say it's an Amazon operating system, then it better be Amazon all the way to the car, because that's how you can push something down and it'll still make sense. You should not change APIs in the middle. Our belief in Nutanix is that if we can create an operating system that can span the edge and the center and be democratic, then we have a shot at it and becoming the OS for these complex systems that will be built in the future. That should explain why we focus on IoT as well. So our OS runs in IoT devices, and we also want to run our OS on the big clouds. And that gives our customers the ability to create this, the cascaded data center, if you will, right, starting from the big all the way to the core. And that will be a challenge actually. Next 5-10 years this will play out. What's the OS that will win? And maybe not one winner. Yeah.
So your operating system will at the end work with APIs to the service providers.
Oh yeah. So this is So basically, the operating system is running on top of some devices, right? And this is device drivers that are written. So that's the analogy. So Nutanix running on AWS, we have networking device drivers, right? So now we have natively integrated with AWS networking, right? So similarly, wherever we run, we'll natively integrate, and there's multiple drivers written, but in a way that the app that's written on top sees a uniform running environment.
Okay. I raised a question also to Jira earlier.
Yeah.
What would IT have been if there was no Nutanix? So 10 years ago, Nutanix was founded. They created the hyperconverged infrastructure, and the industry followed that to a certain extent.
Correct. Yeah.
But if there wasn't a Nutanix, what was not possible but it's currently possible? So what was the impact?
I'll answer it two ways. One, if it was not Nutanix, I believe it would have been somebody else. Because for startups to succeed, they need to get the timing right. I was in a startup where the idea was similar to what Nutanix did, but it was 8 years, ahead of its time, and it failed. So, and when the timing is right, what it means is that there is a secular demand for it. And if one startup fails, the other one will succeed, right? So the first part of your answer is, if it was not Nutanix, maybe 2 years later, somebody would have figured out that this is needed and they would have done it. Okay. Second part of your question is, okay, what if hyperconvergence was not invented by Nutanix or somebody else? What would have happened? Say we are sitting today and there is no hyperconvergence, and the public cloud is basically developing as fast as possible. I would say we would be sitting in a situation where the enterprise data centers would be just shutting down rapidly, because it's an apples to oranges discussion. You have this legacy infrastructure that cannot scale, is not flexible enough, and it is absolutely no comparison to the public cloud. And the whole world would be just moving to the cloud. Early days, the pendulum was far to the right. Everybody said yes, cloud is going to win 100%. That pendulum would have never come back to a more sane middle ground if there was no HCI. But then that would not have happened, because just like HCI would have happened, Nutanix or not, this would have happened, because infrastructure will never be rent only. I mean, I need to buy a house, I need to buy a car, so I need to buy stuff. If I know I'll use it for 5 years, I better buy it.
And where will we be in 5 to 10 years? Okay, you already predicted that the cloud will be completely integrated in the OS. You are hoping to be the OS of the market.
Yeah.
What more can we expect? And changes in the IT. If you look at the whole IT, for instance, the volume of data storage.
Yeah.
We will come to the end of the magnetic storage. There will be a limit at the end. It's going that far.
I worked in IBM in the division that invented the disk drive.
Yeah.
And for 50 years people have been saying, and the tape drive, and 50 years people have been saying that tape will die. That hasn't happened.
No.
And disk will die. That hasn't happened. I think there is something fundamental about magnetic storage that is unique, and it's very hard to mimic it with solid state, right? I mean, performance is set apart, but the fact that I can take very fine field domains of this magnetic media and wrap it on top of each other in a tape, that gives me immense density and immense shelf life. So I don't know whether these things will die. May just stay there for a long time. But storage, I mean, data will grow exponentially, because our capacity to, I mean, you're just creating a video out
that's gigabytes of data,
right? So our capacity to generate data is going to be exponentially growing, and we like to preserve everything, and storage is going to get cheaper and cheaper, so we just store tons and tons. What's going to happen is earlier there was like, okay, there's a storage system I have. Okay, that's the storage system, and I store everything there. That's not going to be true anymore. You'll have a tier 0 storage system where you keep your databases and where you churn data, right? You compute and modify data all day long. And then there is this other tier where you keep data for a very long time.
Yeah.
Object stores have already come up, so we're already seeing that. Object storage for this deep, long storage. And then there is this higher, faster storage coming around 3D crosspoint, NVMe, this is the other extreme. So storage is actually now splitting. It's no longer one system. It's actually again a hierarchical system. And that's how it's going to be built. From an IT admin's perspective, the way computing is going to change is, the location of the data center is going to get more and more, fungible. It's like IT will say, okay, I need to deploy an app globally. And now it's because this OS is global, and there will be a costing analysis saying that, okay, you want to deploy this app globally, what is the latency you want from, say, Shanghai or Tokyo? You give me the latency, and I'm going to shop in the market, figure out the right place where you should rent and all that, and deploy your application and charge you for what you use. I predict that's going to happen. So IT will become a very different thing. It's not that you touch infrastructure, it's more around consuming it globally. Yeah.
Service,
yeah. And business value on top.
I think we're running out of time, isn't it?
We have just a few minutes left until 5:30, and I don't know if you plan on going to the evening keynote.
No, I don't think I can make it. I think we covered almost anything I had on my list.
That's good.
Yeah, I think we have all the questions. Yeah.
Awesome.
Okay, wonderful. Have we exhausted